So I saw this study yesterday, and it's an old study. It was published in 2014, but it kind of gave me a light bulb moment, and I wanted to share it with you. So the light bulb moment I had came from this line in the abstract. It says, in the brain, creatine not only reduces lipid peroxidation and improves cerebral perfusion, so meaning the amount of oxygen and nutrients getting to your brain, right? Its interaction with the benzodiazepine site of the GABA A receptor is likely to counteract the effects of glutamate excitotoxicity. So to understand how super exciting this is, I'm going to have to back up a little bit, okay? So I think a lot of people know about MTHFR mutations in folate and autism, but let me explain if you don't really fast. So you have a gene in your body called MTHFR, and its job is to activate folate into a form that can be used by the methylation pathway to make this guy called S-adenosylmethionine, or SAM. MTHFR is the rate-limiting enzyme of that pathway, meaning it's the slowest guy in that pathway anyway, so nobody can go faster than he can go. So when you have mutations in MTHFR, it not only slows down the folate pathway and kind of backs it up, but it also limits the methylation pathway, meaning you don't have enough SAM. Now, low levels of folate, active folate, which is the methylfolate, and low levels of B12 in your blood have been associated with the development of autism in the children of those that we tested, right? And we've known this forever. That's not new research. We've been concerned about MTHFR, folate B12 in mothers and developing symptoms of autism in their children, right? Or even things like neural tube defects. Now, one of the theories of autism is the fact that these children have glutamate excitotoxicity. Now, there is not a central theory on autism, and I personally don't think there will be. I think that there are many different causes and contributors to autism, and this is probably just one of those. So I'm not saying this is happening in every single child or every single adult for that matter, right? Because we got lots of flavors of autism too. But the theory of glutamate excitotoxicity is founded on the principle that glutamate is a very excitatory neurotransmitter. It hypes everybody up there, right? GABA is your calming neurotransmitter, and glutamate is converted in the brain to GABA. This is supposed to be a regulatory mechanism, so you get hyped up when you need to be hyped up, and you get calmed down when you need to calm down. The problem is when you have too much glutamate for too long, you excite those neurons so much that it gets toxic to them and can actually damage and kill them. So now that we're caught up, right, let me tell you my light bulb moment. 70% of all of methylation goes towards making creatine. 70%, right? If we have deficits in our methylation pathway, say it's just running slow, we don't have enough SAM, right? Because we have MTHFR mutations, we didn't have methylfolate available over the counter until recently, right? And there honestly hasn't been a lot of pressure on the methylation pathway until recently, until post industrial revolution. So if you're just not running the methylation pathway enough, if you don't have enough SAM, you're not going to have enough creatine. Meaning you're not going to be able to counteract the effects of glutamate excitotoxicity and calm everything down. Meaning that this actually might contribute to the development, possibly, in part, or I'm not saying it's the entire thing, of autism and the progression of autism symptoms in children. But what's really cool is that glutamate just doesn't have to do with autism, right? It also has to do with brain-mediated pain disorders. So pain disorders like fibromyalgia or like CRPS. Now, they're not all centrally mediated, right? There are also very significant other parts of those diseases that aren't just brain-related. And I'm not saying that they're in your head. I'm saying that they come from your head, right? Your brain's in your head. So obviously these are in your head because your brain's there. But they're not made up. Glutamate has a lot to do with things like anxiety. These are all increasing recently, in known history, recent history, things like fibromyalgia, chronic pain disorder that is almost a constant pain that you feel all over your body that you can't really tell where it's coming from. Anxiety, things like that. Now, when these neurons burn out, it can cause depression, right? As a side note, I don't think the incidence is increasing in this, but this also can do with schizophrenia. If you have too much glutamate too long, it can cause you to develop almost schizophrenic pathologies, right? So this is wild. This was my light bulb moment yesterday. I just wanted to share. Do I think that we should supplement children with autism with creatine? It gets a little dicey, right? It might be good at lower doses with children with autism, and people reach out to me and say, hey, if this is your kid, what would you do, right? I might try just a little bit of it, but creatine is one of those things to where you can get a really bad source. It can be contaminated with all kinds of other things. So you've got to make sure that it is actual creatine. It doesn't have any like metals in it or anything like that. But also creatine is really hard on your kidneys. If you take too much for too long, it can decrease kidney function. So this is one of those things that go really, really slow, start very low, and increase, and then understand when the kid gets sufficient in creatine, it can actually start to develop like bad side effects from taking the creatine. And then since you're supplementing creatine so much and your body doesn't need as much folate, right? You can actually start to develop symptoms of methyl trapping by taking folate. So you can develop anxiety, irritation, anger, stuff like that, because now your methylfolate dose is too high. And this is just an indicator. It's not an indicator that like it's bad for you now, or that maybe you need to stop at cold turkey. It's an indicator that you need to pull all the doses way down and then start to like figure out where the happy zone is again. So anyway, this was really cool. Just for the so you guys know, glutamate is converted to GABA by the use of vitamin B6, which I don't know about this enzyme. It's the GAD enzyme. Most of the B6 enzymes are lysine dependent. So you would need B6 and lysine to run this, probably. I can look it up. I'm not sure about this one specifically, but lysine generally doesn't hurt people, right? But this was really cool to me. A lot of people take creatine, like if you've not slept really well just one night, we can't like override a whole week's worth of bad sleep. But if you haven't slept really well for one night, you can actually kind of recover function a little bit with a dose of creatine. And I don't want to give you doses because they're like very specific to you and like how things are running. But we see great things about creatine. People typically overlook the kidney impacts. So like be very careful. But this was really cool. And I wanted to share.